Welcome back to Data Innovation Summit 2018. The next panel, we have esteemed guests, Errol Koolmeister, Anders Arpteg, and Garance Legrand. It sounds like an artist name. You sure you're not a famous artist? All right, so we're here to talk about data science and impact to the business. We have lots of questions coming in from the attendees today, from the delegates. And so how about we do this? Let's just hit it off a little bit, and you tell us about how you work with data science personally in your current roles. Anders.
Yes, thank you. So we focus a lot on deep learning right now at Peltarion, but we want to work with projects that are rather diverse. So we try to do anything from simple sales prediction to generating music, or to predict the weather, or to actually we have this kind of card flow prediction. A lot of different things that try to capture different aspects of what really difficult problems are and how you should work with them. So we try to apply the latest techniques, basically. Mm-hmm. So for music generation, you use this kind of latest dilated convolutional nets or transformer models, etc., to try to see how we can understand these kind of rather difficult data sets that are, if you take audio, for example, it's a very long time series, which are basically 16 kilohertz, for example, of data points per second, which requires kind of advanced and large model to actually understand these kind of long-term patterns that exist in music. So you need to really resort to real state-of-the-art models to handle that. Mm-hmm. So that's at least one aspect of it.
Cool. Garance?
Yeah, I work with PwC in Sweden, and I'm working as an AI and machine learning advisor.
Okay.
Earlier, I was working for Teradata for a number of years as data scientist. Mm-hmm. And my current role is more focused on looking at the organizations from a broader perspective and looking at the enablers and hurdles, actually, that are holding organizations from creating value with data science, with machine learning. Mm. And PwC is very strong in digital transformation projects, and the projects that involve strong change management components. And so we use those strengths to lead projects that involve data and analytics and weave it into the organization, basically.
Cool. Errol?
Thank you. Today I work at Teradata, and I work as a practice lead, the director practice lead for Nordics, Eastern Europe, and Russia. So basically working with the largest companies within this region. I lead a team of about 25 data scientists. So what we do is basically we go in with our customers and we try to identify the high value use cases. We have our data scientists working on these problems together with our data engineers and obviously industry consultants. We go from different industries, so we are in banking, telco, retail, etc. And we only focus on the kind of the really complex things. But it's not just about data science as an isolated thing. It's about an ecosystem. We talk a lot about how do we go to production with data science? How do we get these things from the kind of the use case, POC, value, identification part of things into the value realization? So data science, and coming back to the topic of this discussion, is about extracting value from data. And we think that 2018 is really the year of value. It's a year of automation. This is a time where we stop doing POCs and proof of values and actually do it and getting things back.
That's super interesting. I'm going to get back to that. But as the audience sees, what we have here in common is three people that are quite well versed in data science. And I think one of the reasons this particular session might be popular is because a lot of stuff that data scientists do seems pretty exciting. Cool models or real business challenges that are being solved and that kind of thing. So people that are looking to upgrade from experienced software engineer or database administrator or something and are looking to take the step up to data scientists, what would you say are the steps? Let's assume that understanding mathematics is there. What are the practical steps that people should be taking now to get ready for the data scientist revolution?
So if you have been working, let's say you take the database administrator example, and they perhaps have some understanding of math, but probably need to understand a bit of theory as well. We have this kind of classical Conway Venn diagrams that talks about the theory, the engineering, the actual domain expertise as well. So obviously need to try to focus up on those. But what I think they miss a lot on is, for one, communication, and I would say second also, like attitude or curiosity. So for one, you need to have the curiosity and passion for really trying to understand these rather complicated models sometimes to be a successful data scientist. And with communication, which probably a lot of people talk about, but really don't really know how to train on. How really do you become better at talking to people outside of your domain, to speak to perhaps business people or product owners or other type of people that doesn't work with data science? That is something really hard, but you need to practice a lot on. If you do that, then that's really a key to become a successful data scientist, I would say.
That might require you to go outside of your comfort zone,
Yes.
I think, for a lot of people.
Yes.
What kind of skills do you think are important?
Yeah, I mean, I definitely agree that communication is a really important skill, actually, for data scientists to be able to communicate to different audience, more or less educated in analytics. And I would say, curiosity and a drive to solve problems, actually. It's really a problem-solving competency. And I think in terms of creating a successful data science project, probably the key is to understand well the problem. So in really having a drive to dig into a problem and understand all the facets, and doing actually most of the work that is going to allow for a smart solution to emerge.
Interesting question. I think let's start by being a little bit more philosophical. So what is a data scientist? I mean, obviously, in order to do a transition from one place to another, you need to first define what it is you want to transition into. The data scientist has now been described for a very long time as the unicorn that's going to solve all of your problems. Honestly, that's not a feasible business model for anyone, to have one person or a team of unicorns to do everything. If you're a database administrator, or if you're working as a software engineer, and if you want to do the transition into data science, first see where you want to go. Do you want to be a specialist within data science? Do you want to be a machine learning expert in a particular algorithm, or a particular industry, or a particular problem? First do that identification of where you want to be. Then, and just then, you can really go down and see what are the skills needed to be there. Do I need to improve my math skills? Well, obviously you can either go back to university, take more math courses in that particular topic. You can go online, get certificate in that particular problem. If you're going to be the unicorn on anything, and if you're only beginning your journey, getting to the unicorn state is not a one-day journey. It's a journey that never ends. A data scientist philosophically covers so many domains, as you mentioned, taking this Venn diagram. If you're going to cover all of those topics, you're never, ever going to be done. A data scientist today is a journey that's constantly evolving. So it's very, very philosophical. It's not an easy transition. Everybody can call themselves a data scientist, but are you a data scientist? Who gives a certification in data science? Is it because you took a master's in data science?
I don't think the title is especially important. I think it's a little bit like with music. Anybody's allowed to be a musician.
Yeah.
And then you can be a good or a bad one. And that's another matter
Exactly.
entirely.
Yeah.
So the title isn't so much what sets us apart. But let's be a little bit practical here. In terms of math, I know what a percentile is, and I know what the mean and the median are. And I think I heard about a Poisson sampling or something in university, but I was sort of asleep also. So, what more is there to know? What am I supposed to learn beyond? I mean, a lot of people know some basic algebra and maybe some linear algebra. What more is there to know?
If I got to start, I certainly, given I have actually taught at universities as well, so I really want to try to improve what they do teach in universities today. I don't think that's really well fitted to what companies need. But if we are going to talk specifically about math, there are stuff like linear algebra, or something that I think they should teach much more would be complexity theory, trying to understand algorithms, trying to understand how much time will it take to actually train the model, and to understand what happens if you change a certain algorithm in a certain way. to understand both the memory and time aspect of that, I think something that is not taught sufficiently today.
So software engineers might be better equipped to do those kinds of calculations in their mind.
Yes, but even with more focus on algorithms than I would say.
Right.
So there are a lot of things that is important for math. So a lot of people underestimate and talk down the need for math. And I even had a Russian math professor once, and I asked him that specific question, saying, I'm never going to use this calculus math. Why am I really going to need it? Actually, we do need it in deep learning today, which is kind of interesting, but normally you don't. But he said an interesting thing, which I think is a bit sad, saying, you learn math to show that you can, not that you need it. And I think that's a really sad view to have. And I think you can actually teach math in a way you have direct use for it, especially in data science.
Well, my colleague that does string theory, he says that mathematics is about proving things. Everything else is arithmetic. So we're not really learning any math in schools nowadays.
That's true.
But what about programming then, in your opinion? How important is it? People that have been doing BI for years and they want to become data scientists, how important, and they say, well, I've programmed in SAS a little bit maybe or something like that. How important is it to be able to program if you want to do some serious data science?
I think it's very important. Especially in the current sort of tool ecosystem that we have. Yes, there is like an emergence of tools that makes data science more accessible to non-programmers, to non-coders, but it gives a lot more flexibility to be able to code your own analysis. That said, the data scientist is not just a coder. So, like what we've said before, it is really a mix of skills. You can't be just a mathematician and expert on algorithms without having some foundational knowledge, basically, of programming, and without an interest for the business and visualization and communication.
Right.
I think I have to throw in this really infamous quote from, I think, Josh Wills or something. He said, data scientist is a software engineer that knows statistics better than any other software engineer, and he knows software engineering better than any statistician, right? Something like that. I think that's actually a funny quote to say. This weird person that doesn't exist.
Yeah.
And how is it then, the relationship between, last panel we talked about the clickers versus the programmers. How do you see that relationship playing out in terms of the data scientists in the company? What the ratio is it going to be?
The ratio. So back to, I think, your previous question, do you need to know programming? Programming, and I think maths, are a way of thinking. It's a way of approaching life. I mean, you need to have, programming, when I learned how to program, a new world opened up for me. I realized that I could do things, I could create algorithms. It gave me an understanding of problem solving. It was applying my thinking into code, into logic. It's a way of logical thinking. The clickers obviously need to have some sort of logic, but they don't need to understand the process flow. Somebody else understands it for them. I do think that in order for us to meet the demand of data scientists, we need clickers as well. Some things you can automate, but you can't automate the most of things. So the cutting edge things, the things that actually are changing the world slowly, the pioneers, the avant-garde, they're going to be the programmers and the mathematicians. The followers are going to be the clickers.
Right.
However, how that's the distribution between the clickers and the programmers going to look, only time will tell. I think we are going into a world when you'll start to learn how to program already in middle school.
Right.
I mean, we can see it in Sweden. So. Yeah, I hope so as well. We can see it in Sweden as well. I mean, there are suggestions that you start coding in grade 5 or 6, which is a major thing. And I think it's a way of changing. We are living in the digital era. And in order to live in the digital era, you need to understand how it works. Not maybe be the most advanced programmer, but at least know that logic guides the thing that we use.
But everybody knows that in order to be good at math, you have to try it more than once. So, right, it's not enough to see the formula on the board once. You have to give it a try a couple of times on paper. And it's the same thing with programming. You have to do it over and over. But if we tie it back to math then, what kind of statistical mistakes might software engineers be making that people that come from a mathematics background might make? So, we have some of the big names, Simpson's paradox and those things. Are those genuine problems that they will be encountering? Sampling issues, that kind of stuff that the pure statisticians will be like, you will never know the purity of my discipline. Is that real?
I think for one, it's important to make the distinction between math and statistics. And I even like to use the term like data common sense sometimes. If you have the understanding of data or a common sense for what a histogram really means or how a certain type of data should look like for a model to work, then you have that common sense that is super important for an experienced data scientist. So building up that common sense for data is, I think, what the best type of statistics really is about. So I wish we can do that. I think, just going back a bit to the ratio between programming and clickers, today, certainly, it does require you to be a rather advanced programmer to use at least the state-of-the-art type of technique. Hopefully that will change over time. So I think the ratio is today heavily tilted towards programmers, but I think over time, tools will evolve that will actually allow it to quickly move in the other direction. And in that way, actually make these type of techniques, which is really powerful, available to so many more that can't do this type of programming that is required today.
So just adding on, I mean, you have the people that loves to write the math themselves in programming languages. You have the people that love to import libraries with pre-written mathematical functions. And then you have the people that love and understand the math, but they want to be able to drag and drop it because it's easier for them.
I wouldn't say they want to drag and drop. They probably want to solve a business problem.
Yeah.
I think the main driver for them is not to solve a math problem. The main driver is really to make the sales go up in the company, perhaps. And they don't really have the tools today to do that. They have to leave it up to someone else to do it. But they want to be able to use with tools to be able to perhaps drag and drop it so you can solve the business problem.
Yeah.
I think
I fully agree with that one. One of the things that's always driven me to learn more about programming is because I realized if I only use one tool, I'm limited to that tool and that options. But if I learn Python, if I learn R, and if I even learn Julia, I will have other options at my hand. It will give me more weapons in my arsenal, and it will give me more productivity. But if you are in a company, for instance, you want to solve the business problems, and they have bought a license to an expensive software, you're probably just going to use that. You're going to be limited, but you might be productive.
Yeah.
Well, we just used Paint to edit arrays this week, so you never know where big data tools can come from.
You never know.
All right, so you talked about going to production.
Yes.
And instead of living in a bubble, what would you say has prevented people from going into production previously? You make your cool models, or the model makes good predictions. It's a far cry and like a long jump into putting into something that sits there automatically, that you can rely on producing good results, that has the necessary throughput and all that kind of stuff. What was missing and what's coming?
I mean, if you work, there are differences obviously from company to company, but take large corporations. Usually there is a department doing data science or doing AI that has a disconnect from the productionalization systems. If you're, for instance, working with a data warehouse, it might be easy to write a model and integrate it. However, maintaining that and doing the maintenance, the follow-up, and having a continuous improvement cycle, that will only limit you to about 5 to 10 models before it becomes too much. I think what has really starting to hit the plateau right now is that you're limited by the amount of work your data scientists can do and their connections with the IT and production systems. If you start thinking production before you start modeling, you will then start defining how does the path to production process look like? How can we automate as much as possible? And how can we ensure that we think production before we start modeling? You can't solve all the problems before you actually go into production, but if you start thinking production from day one, it will be so much easier when you hit there.
Right. And how many models do you think are built just for analyzing something, and how many are built in order to be put into production to be run against a stream of data? Because sometimes I find that, I build a model just because I want to use it to look at something, and then once I've looked at it, I'm done. How do you see scientists, do things need to go into production? Maybe most of the stuff that they do doesn't ever have to go into production.
I think not everything has to go into production. It really depends what is the business questions that you start with, basically. If it's something that has the ambition to change the operations, to come closer to the frontline people, then of course you have from the beginning to think of the IT industrialization, but also of the change management in your operations. And I think that's also a component that is often under-evaluated, basically. So you think of it when you get there, basically. So the people that are going to use basically the results of the analytics are informed that they're getting something the day it's arrived, but there's very little preparation, and that hinders a lot their acceptance, basically, of the analytics. But then there's a lot of business questions that are, to build a business case, for instance, that are just about gathering the right insights. Maybe it doesn't need to go into production.
Right. Well, let's see. I had one more question.
Can I just add on to that? I mean, when we talk about productionization and extracting value, as you said, you need to identify what is productionization. Am I going to produce a score? Am I going to produce insights? Am I going to do batch? Am I going to do real-time integrations? So productionizations can be anything from a PowerPoint report that's used once into a continuous cycle of scoring. So it fully depends on where you want to extract value of your models.
Right.
Some companies might think it's sufficient for them. However, when I think about productionization and value extraction, it's about doing repeatable processes over and over again. That's the really, really hard part. And that requires a lot of thinking.
I can add just a story. I mean, for one, Google had this paper for a couple of years ago saying, the hidden technical depth of machine learning, saying basically 95% of the time you actually spend just working on tooling and glue code and plumbing work. And that is the situation today, unfortunately. And people continuously underestimate what it takes to go from a prototype to a production-ready system. That's for sure. And that's one big reason for why a lot of data science project doesn't really gain value, and also why some people lose trust in data science. I'd like to actually quote Daniel Ek from Spotify. He actually said a very interesting thing, which is, we are going to fail fast. And if you don't understand what that means, it sounds like a bad thing, but it's actually a very positive thing. And if you have a situation or a company and understanding in the whole company saying, most of the projects we're going to do are going to fail, but the one that do succeed will be really useful. If we then can build up an infrastructure where you can experiment a lot, be innovative, and quickly fail, so that the actual product do work can quickly be put in production, that is when you have a successful setup for using data science.
Amen.
Let's see. We have some questions from the delegates that we can tick off. Big tools. How important are tools? How important is it that you're using, the latest underground programming languages or that kind of thing in order to be a good data scientist?
So, have you heard the expression, a fool with a tool is still a fool?
Okay.
It depends. I mean, it's data science, it's problem solving, it's creativity. A good tool enables you to do that. A good data scientist can extract value with any tool. Some tools are better, some tools are worse. I say, look on your situation. What do I need to accomplish the best outcome with the most value in the least amount of time? Let's not name any tools, but it's going to be that way going forward. You can't just pick a tool and think that will solve all of your problems.
Right.
So I think tools are super important. I think you can compare it to another area besides data science. If you take software engineering in general, compared to data science, and compare the tools that you have for software engineering, they are really mature. They've been around for like 20 plus years. Data science and the latest type of techniques, few years. And it becomes very apparent when you want to put something in production that the tools are horrible. And that's unfortunately true today. I even spoke to a person at DeepMind once, Sander, who we asked him, what do you do at DeepMind to actually have the proper tools and quickly do experimentation and be able to structurally compare results, etc. You must have some awesome, piece of infrastructure to use at Google. He said, nope, I built my own. I have my full tech stack just built by myself. Like, what? Really? Yep.
But that ties back into what you were talking about before, where that so much time is spent on tooling and that kind of thing.
Yeah.
And I've had a number of people that I've done interviews with for hiring here at LakeTide and that kind of thing, and heard that a lot of people are under the impression, especially new graduates, that they're going to be sitting and tuning hyperparameters and getting the model to perform better and that kind of thing, and they don't really have time for all the nitty gritty, getting containers working and getting all that kind of stuff. Is that still where we are, and will it be that way for a time, for quite a while in the near future, you guys think?
I hope we're not going to spend our time optimizing models, because I think that sucks the life out of data scientists. And I think what really brings appreciation into the profession is when things are visible, basically, into the organization.
I think it's great that you say that that's not the best part. That's what a lot of people just think, that the optimization is the best part.
You can automate most of those things, well, anyway.
Yeah, grid search.
Yeah.
Like your whole role is gone.
I just had a headache.
Oh,
use machine learning to do machine learning.
Oh, yeah.
And then your job is done.
Auto ML.
Well, what about creativity? So, I want to do machine learning. I've gone to a blog and I found a Keras walkthrough on image recognition. Now what?
Well, it's hard to. How do you teach someone to be creative? I think curiosity, passion, and a knowledge, or just a thirst for understanding stuff, is also what drives creativity in some sense. If you know what a lot of people do and can talk to a set of people regularly, that will give you a lot of information and ideas of how to solve your specific problems. So being able to really take solutions in other areas and apply it for your own problem, if you can start to do that in a creative way, I think that's a really great situation. But that requires you to actually go out and seek information, talk to people, and learn from others. And that's you need to have curiosity to do that.
I think this is a...
Can you guys give example of curiosity? I think, like in psychology, people talk about critical thinking skills, almost as if it's something that's measurable, that and that you have to practice also. It's not simply, we do images, maybe we can apply image recognition. I think the really big sources of new revenue, big business models aren't going to be that obvious. You have to be fairly creative to come up with how to apply machine learning in ways. There's not going to be a Keras walkthrough for your application on your business model. So what kind of creative ideas have you seen from data scientists that you thought, that was a clever use of machine learning that wasn't even necessarily technically advanced? It's just neat to see a clever hack.
So we have a really good use case for that. We were doing with Danske Bank, one of our customers. We flew in one of our deep learning experts. They had a really interesting idea. We were doing fraud classifications. So we were having fraud transactions being brought in and streamed in real time for our online banking fraud. So that data scientist said, I want to do deep learning, but I want to use convnets to do that. And I want to do image classification. So they had a brilliant idea. So let's take the fraud transactions and transform them into image and do image classification on it. And it yielded amazing results. It was just something like, wow, how did you think of that? How would anybody think of, let's transform it into an image and do image classification of it? So I mean, sometimes you just need thinking, you just need to be in the right setting, you just need to have a mindset that goes, I don't like the expression outside of the box, but this is really thinking outside of the box. Try something new. So you take something, I mean, image classification is out there, the architecture they use is very well known, but it's the idea of transforming data that's not an image into an image and getting the results. So I think it's a process, and it's about passion as well. So when I do interviews, I look for the attitude and the passion. I might have somebody coming in for an interview with a PhD and looks really good on paper, but they're very blasé. They don't really care. They think they're the best of the world. And then I have an undergrad student with a bachelor or something that is just fire about a topic. They can speak so much, and he says, I'm in all the communities, I work non-stop. I haven't nobody taught me this in school, but I went online. I took all the courses. I just love this. I want to do it all day. I'm going to hire that guy over the PhD any day. It's a mindset.
Plus, I have an after-school linear solver club. Everybody that loves linear solvers can come and...
Yeah.
But I think for people that are aspiring to be data scientists, there should be things that they can do to cultivate creativity in a way. I think, in my opinion, analogies are things that help you come up with creative ideas. I think when you speak about a person on an advanced subject, there's a joke in Kung Fu. When you ask a beginner how to kick, they'll be like, here's the kick. When you ask an expert, they'll be like, oh, you have to turn the hip, you have to turn the leg and stuff. And there's lots of little steps. And when you ask the master, they'll just say, I just kick the guy. So it goes back to simple again. And it's the same thing I feel with being really technical. When you ask about machine learning and stuff, when you get advanced and you start to learning the details of it, you'll talk about specific activations or whatnot. But after a point, people are just talking about what's the model paying attention to, and you have a little bit more high level analogies, and but it's easy also to be fooled and think that those analogies, if you simply know those, then you're an expert. So how do you find that balance between domain expertise and reaching the level where you can be creative with it?
One view, I mean, if you compare someone that is perhaps less experienced, or let's say some people are really into math. They really love to understand something from a more or less mechanical math point of view, step to step how to solve something. Another person may be more interested in trying to understand the intuition behind why someone designed a model or a solution in a certain way, and then connect it and understand it another way. But if you don't have that connection, or at least don't try to think in intuition terms, I think it's really hard to be creative. So try to find these analogies, as you say, or at least try to have some kind of internal intuition for what a certain solution or model actually do. That is the way to be able to connect it to completely other models that have perhaps a similar intuition, but completely different math underneath.
Right. So learning, that's interesting. Let's hook on to that. Different people learn in different ways. So like you said, some people really want to understand every step, whereas some people want to see the goal first. And some people, what do you find are good ways to ramp people up in terms of learning? There's a lot of online resources, and what has worked best for in your experience?
I think the short answer is learning by doing, really.
Learning by doing.
And I mean, to come back to this question about creativity, I think creativity spurs a lot in the meeting of people who have slightly different background or slightly different experience. And so the learning happens also in those stages, basically, where you're exposed to something new, not in maybe in the most academic setting, really, in a course or in training, whether it's online or offline. But it's more in those moments where where you're like pairing up with someone who's got a slightly different skill set or a slightly different take on a problem, and then you can escalate into a smarter solution.
So what's better, small projects or big, super complicated and challenging ones? If you want to learn,
If you want to learn
yourself, yeah.
Well, it depends on what it is you want to learn. Obviously, you learn different things from those things. I think early on in your career, be exposed to many small things if possible, because it will give you exposure to many different things. It will give you insights into different algorithms and different problems, different settings, different people. So you'll gain a lot of small insights in a lot of different places. In order to be able to fully deliver in a large, complex problem, unless you're just a small cog in the wheel, is to actually have that experience. You will learn a lot from a really large-scale project, but it can also be very tedious from time to time because progress and the goal is very far away. So a lot of people don't actually have what it takes to spend 2 years on a project, working with the same data, working with the same infrastructure day in and day out. So if you're new, try not to jump on the big things. Do all the small things before.
Well, let's tie this back into Teradata.
Yep.
That has big appliances, big projects, big customers. Well, when you're learning, you can, if you want to learn Hadoop, you can buy Raspberry Pis and install your own cluster, or you can load up a VM. There's many. You can go the big way or the small way. How do all these big data tools tie into the role of a data scientist? I think a lot of people now are thinking data science is equal to machine learning and perhaps presenting results and a little bit of data analytics. What about big data and the tooling? I find that if you're ignorant of those, you're at a severe disadvantage.
I mean, big data and big data processing and applying machine learning to big data problems is a completely different idea than doing it on smaller data sets. You need to understand the parallelism behind things. You need to understand how to optimize, and you need to understand clusters and how these things work. Usually working with big data, you want to have Spark, you want to have Optimizer, etc. So if you are in school and you don't have the possibilities to work with these tools, and you go out and you find a job with a big data company like Teradata that does a lot of these things, you're going to see that you will find a lot of problems. I remember the first time I went on a big cluster and I was writing Spark jobs in Scala, and I got out of memory errors all the time. Or when we were having Spark jobs and everybody were competing about the same executors, but because we didn't use dynamic allocations of the resources. I mean, these are things you need to understand and learn unless you want to really bring down the project. I've had projects on big data that actually didn't deliver because we were all very ignorant about the big data problems.
Does this fall into the scope of a data scientist to know these kinds of tools?
It does, but I think the data scientist is breaking up into different roles, because I would put this more into data engineering, into revising basically the solution.
I wouldn't.
No?
I wouldn't put it as data engineering to understand parallelism of different algorithms. You can't run all algorithms on a big data settings, so you are limited from time to time on the types of algorithms. Potentially, as a data scientist, you don't need to understand all the engineering aspects of it, so you might be right on that thing, but you do need to understand what algorithms can I use and the concept behind big data processing. That's a big difference. So data engineering, yes, but we are looking for a blend between understanding the math, understanding the engineering, and understanding the domain for data scientists. So obviously the person that's really good on data science at scale would be somebody that's a little bit stronger in the data engineering side of things. And also you can then limit some of your understanding of certain algorithms because they don't apply to the big data world.
It doesn't take much to get into the big data domain. You can have just a big set of images, or you can make your own data set. In graph algorithms, when we're making training data, you just generate data that's impossibly big, and then it's nice to know how to do out-of-core computation and that kind of thing. Do you feel like it affects your company a lot?
From the days in Spotify, I, of course, used a lot of big data tools and think that's really fun from a passion point of view. I do think, though, that most companies, and a lot of companies, do exaggerate the need to use these tools. And actually, I mean, it will increase in need as we use more IoT and have more data coming in. But if you really want to solve a problem, a more pure data science problem, I think you can, in many cases, just reduce and sample data to a small enough size you can actually work with it on a single machine and solve the problem potentially much more faster, and then later scale it up. Unfortunately, today you have to, as a data scientist, more or less know these kind of big data tools. I hope that in not too far long future, we don't have to have that much of detailed knowledge and the horrible, out-of-memory stories. I've been there as well, and it's really awful. And trying to troubleshoot in these domains is just crazy. So, I mean, it's not a good situation to try to develop something in and test something in. It's horrible. And I hope it won't be too far in the future where we don't have to design the stuff there. We can scale it up to put it in production in these kind of tools, but hopefully we don't need to develop there.
Right.
And with the advent of more GPUs and more deep learning coming in, actually you can do a lot of stuff on a single machine with some large GPUs in it today.
Absolutely.
I think we need to acknowledge that different tools are needed for different problems. I mean, a few years back, I mean, it was the data lake, it was the data warehousing. We need to go into more of an ecosystem thinking, use the tools or the software that's actually going to help you with your problem. If you're working in a large organization, don't think a data lake will solve all of your problems. Data warehousing, NoSQL. have a NoSQL database for those use cases, have a data warehouse for the regulatory reporting part of things, big data processing and data collection, use a data lake. And in addition, you need something to glue it together. Use Kubernetes, deploy Dockers, do these things to glue the infrastructure together. And then you can have people that are specialized in the different components of it. So it's not just a one unicorn data science aspect of thing, it's a team effort. Have people specialize in those different and have them working together depending on the use case you're working with right now.
All right, we have a couple of minutes left. And a term came up earlier that I'd like to ask you about. People were saying DevOps, and I've heard the word ML Ops, and we just coined the word Data Science Ops about an hour ago.
Analytics Ops, though.
Analytics Ops. So we
Analytics
have
Ops.
even another one. I'll just note it right here.
That was the name of my talk.
So, you mentioned containers and
Yeah.
that kind of thing. Maybe that's not big data per se, but what are your ideas now on the kinds of things that data scientists need to know beyond pure models and statistics with regards to practical computer reality of operations of working with ML?
Far too much. That would be
Linux? Is Linux?
Yeah, I mean, I think we need to acknowledge the big problem we have today with the need to know so many different languages, operating system skills, database knowledge, being able to log and monitor, being able to deploy and scale through Kubernetes or whatever. This is impossible for a single person to know. It's not a wonder that we have such a, scarcity of data scientists, because it's too much to know for a single person. So, I mean, that's a very clear problem that we have. So, yes, we need to know even more tools to manage and monitor. And once it's deployed, you need to continuously monitor and make sure it continues to work as expected. How the heck can one person do that? It's, of course, not possible. And we need, obviously need to have a team. But some people have specialities, others have other specialities. I hope certainly that a number of years we can, decrease these needs for knowing all these tools, so that we can basically make these kind of amazing technologies that AI really is available for so many more, like 100 times the number of people that today can use it. Hopefully can use it in the future. And that would be a bright future, I would say.
So I think the evolution we will see is that we started talking about data scientists, data engineers, DevOps. In the future, in order to make this grow and scale, we need to consider data science and data products into a more product-oriented environment. You're going to need a data product owner, somebody that picks the team, develops, keep a backlog, and actually ensure that these things are working.
Right.
A data scientist itself is not going to be driving the engineering efforts or the value creation efforts. They're going to drive the data science, and they're going to drive the math and the statistics and potentially a few things around there. But in order, you have to see it as a process and a product. Products need handling and needs care, and they need continuous development in order to realize the value. So I think in a few years, we will see more and more companies having data product owners that are not data scientists and not data engineers, but they're focused on product management.
Right.
I mean, I agree that I think the data scientist definition is becoming far too large and broad, really. And I think we're going to see like an explosion of roles to cover actually all those different parts. And I think one important role that's going to come up as well is that in terms of analytic ops, there's a strong technical component, but automation is key there to have to do the least possible. But the governance is also key. So you need to have a person that is in charge of analytic governance, of knowing really what are all the models in production and what status of their life cycle they're at. And be able basically to, and maybe that's the product owner that you have.
So I mean, when it comes,
Yeah,
so the product owner would be that person. So having control over model metadata management, automatically retraining of your models when they're deteriorating in results, having champion models competing in production about getting the best results for a given problem. So ensuring that you're capturing all these things, that you have a dashboard that says, I have this many models, these are running in production, this needs retraining, this is going to be retrained in a few days, this is running real time, this is running batch, this is integrated with this system. And having an overview of all of these things and how they're chained together.
That sounds a bit like a dream. My reality is more like what Anders said. So I'm looking forward to this future.
Yeah, I have a dream.
where we have earlier panelists said that data science will be subsumed under the digitalization part of the company. But I think for sure it will grow mature, much like the way IT has grown mature since the early 2000s, that it will become a reality for every company, not just an individual or a small team of nerds or something like that, but a pivotal part of every large organization.
So just keep in mind, digital is the new normal. You won't talk about digital in a few years. It's just there.
That's what it is.
Yeah.
All right. Thank you, everyone, for joining. Thank you.